Hello, friends. Here we are in Unit 8, 8.4. We are introducing logarithms. So, what is a logarithm? How do we write it? How do we solve it? And specifically, and most commonly, how do we convert logarithms? So, this is going to be using a lot of our exponent properties when we convert and evaluate these logarithms. So let's start with kind of the basics. When we see something like 2 to the x power equals 4, we can really immediately know that the value of x is equal to 2 because 2 squared is equal to 4. Same thing goes for when I see something like 2 to the x power is equal to 8. Again, I know x is going to be 3. But when I see something like 2 to the x power equals 6, I don't know off the top of my head what value of x is to make that a true statement, because that's not going to be a whole number, right? So this is where we have to introduce and use a logarithm. A logarithm is the inverse of an exponent. So when we are solving for that exponent, that's where we use logarithms. So we're seeing in this top right box, a logarithm is the inverse of an exponent. It says log with a subscript, right? That's that little number at the bottom of b of y is equal to x. If and only if, and in parentheses IFF, that stands for if and only if, you've probably seen that in geometry, b to the x power equals y. So notice where b is in both of these equations. In the log equation, b is what we call the base. In the exponent equation, b is also what we call the base. So in both logarithmic and exponential equations, b is standing for base in both of them, and that's the same number. The y value in the log equation is called our argument. You may have also heard that term used in geometry before, like whenever y'all were on the unit of special right triangles or using right triangle trig, when you had something like the sine of 57 is equal to whatever, something over something. 57, that angle measurement, it was the argument of that sine equation. So you may or may not have heard it there as well. But y is called the argument. In a log equation, that value of y, the argument, has to be greater than 0. It can never equal 0, and it can never be a number less than 0. So it's always going to be a positive number. And then that's equal to x, which is the same thing as our exponent. So when we go to rewrite, like I said, is going to be really the most common. Sometimes I just ask you to rewrite, but sometimes you have to rewrite in order to solve. When we go and we see these log equations, when we rewrite it, we always start with our base, which in the log formula is the little subscript number, the tiny number at the bottom. So in something like example 1, if I were rewriting this, I would have, what's my base? My base is 6. Raised to, what's the exponent? That's what it's equal to. The exponent in this case is 3. And that's going to equal what my argument is, which is the y value, which is 216. So one way to remember the way to rewrite this is base is always the same. Switch the other two numbers over the equal sign. So base is the same. And then these two numbers get switched over the equal sign. 3 is now here, 216 is now here. The other way that I use more frequently is base stays the same. Starting from the base, I go counterclockwise. So 6 to the third power is equal to 216. So I make my little circle going counterclockwise. So something like b, start with the base, counterclockwise. So 7 raised to the 0 equals 1. Start with the base, counterclockwise. 21 to the 1 equals 21. Start with the base, 1/5 raised to the negative 1 is equal to 5. So if you can't tell already, this is why exponent properties, specifically like negative exponent and fraction exponents, are so important when we go to and solve and evaluate these log and exponential equations without a calculator. Okay, so now that we've written the log form into exponential form, let's do the other way around. Let's go from exponential form into log form. So remember, base is the same. So this is going to be log base of 9. And then now I just switch the other two numbers. 81 equals 2. Log base 9 of 81 is equal to 2. So it's the same, whatever method you kind of want to use, it's the same for no matter how you're rewriting. Base is a base. The other two numbers get switched, or start with the base and do your counterclockwise circle. So base is the base. So the base and then of the argument is now 0.05, and that's going to equal negative 1. Remember, if you were to rewrite this in the incorrect way, something like this, that would have been a red flag because your argument can't be negative. So you know you did something wrong. And that's because you didn't switch those other two numbers. Log base 16 of 8 equals 3/4. And lastly, log base 15 of the 1 over 225 is equal to negative 2. And these are all equivalent. I'm not solving for anything. I'm just rewriting. And that's important when we do have to solve, or when we have to figure out what it's equal to without a calculator, which is what we're going to do next. Okay, so notice for example 3, it says to evaluate the logarithm. We do not need a calculator for any of these. So this would be something that would be fair game on the non-calculator part of your test or your quiz. So the way that I need to kind of think about it in order to evaluate is actually by rewriting it into the exponential form. It's going to be easier for us to solve it that way. So what I could do here is I could say, I'm trying to figure out what log base 4 of 64 is equal to. So if I rewrite that as an exponential, base is 4, raised to what power is equal to 64. Well, that's a lot easier for us to see that that value, that quote-unquote x, the question mark, is 3. 4 to the third power is equal to 64. So log base 4 of 64 is equal to 3. Log base 8 of 1 over 64 is equal to what? Well, 8 to the what power equals 1 over 64. Think about what kind of exponent you raise 8 to get a fraction. A negative exponent. And then how do we get 64 from 8? We square it. So that's going to be negative 2. 81 to the what power equals 9. Well, we're getting smaller, so obviously we're taking the root. What root of 81 gives us 9? The square root. So that's a 1/2. Exponent of 1/2. 81 to the 1/2 power gives us 9. See how you need to know your exponent properties. Okay, let's rewrite it. Keep going for D. Base is 1/3. Raised to what power gives us 27. So this one's a little bit more challenging, but still we know this. How do I go from a fraction to a whole number, or a whole number to a fraction? Using a negative exponent. So I know that my exponent's going to be negative. 3 to the what power gives us 27. 3 to the third power. So this is going to equal negative 3 because I had to reciprocate the fraction. Okay, let's do another one. 27 to the what power equals 81. Well, this one could be a little bit more challenging because 27 raised to a whole number doesn't give us 81. So the way that I see this is, I know something is in common between 27 and 81. They both can be rewritten with bases of 3. 27 is actually 3 to the third power. 81 is actually 3 to the fourth power. Well, if I'm trying to figure out what that number is, then I can say 3 to the... Hold on, let me rewrite this. It didn't make a ton of sense there. This is 27 to the what power equals 81. So 27 is the same thing as 3 cubed to the what power equals, what's 81? 3 to the fourth. What happens when we raise a power to a power? We multiply the powers. So this is technically 3 to the 3 times what? If you want to put x in place of question mark, that's fine. That might be a little bit easier for you. Equals 3 to the fourth. Notice that my bases are the same. So 3 to the 3x equals 3 to the fourth means 3x equals 4, which means x is equal to 4/3. And I shouldn't say x is equal to because this is just equal to, 4/3. You know me, I write big. Okay. And then last one. 5 to the what, x, question mark, whatever, is equal to the square root of 125. So I'm going to rewrite this. I'm going to take some baby steps. 5 to the x is equal to 125 to the 1/2 power. Well, how can I rewrite 125? That's the same thing as 5 cubed to the 1/2 power. Well, what happens when I raise the power to a power? I multiply the powers. So 5x is equal to 5 times 3 times 1/2 is 3/2. Now that my bases are the same, I know that x is equal to 3/2. So that's my final answer. Okay. Rewriting into either exponential or log form. So when you see something like example 4, part A, notice that there's no base visible. I just see log, and then the argument is 100, and that equals 2. What's the base? When we don't see a base written with log, the base is always 10. That's called the common logarithm. That's in the special bases right here. The common logarithm, if we don't see an actual numerical base there, it's always a base of 10. Okay, so something like example 4, part A, that means I have a base of 10 raised to the second power equals 100, which is obviously a true statement. So when I rewrite something like example B into a log form, I'm not going to put log base 10 of 100,000. I don't have to put base of 10 when I'm working with logs. So if the base is 10, you can just leave it off. You're never going to see log base 10. You're just going to see log of the argument, which is 100,000, is equal to 5. Okay. Now what about when we see this ln? What is ln? That's called the natural log. You're never going to see a base when you see natural log because the base is always E, Euler's number, that approximation of 2.718. So when we see something like the natural log of 148.4 equals 5, I'm really rewriting that as the base of E raised to the 5th power is equal to 148.4. And then the same thing working backwards. When I see E raised to a power equals some number, when I want to write that in log form, I'm not going to put log base E. I'm not going to put the natural log base E. I'm just going to put the natural log. Natural log of 1096.6 is equal to 7. Notice that sometimes I put the argument in parentheses and sometimes I don't. It doesn't matter. It's totally personal preference. However, I find that when the argument is kind of a larger number or has some decimals, I tend to want to write it in parentheses so I don't get confused with what's the actual argument and what's, something else in the problem. So you can put parentheses around the argument. You don't have to. Totally up to you. Okay. Now let's evaluate logarithms without using the calculator. It's going to help if we rewrite it into an exponential form in order to solve. So something like log, notice I don't see a numerical base, so that means my base is 10. So 10 to the what power is equal to 1,000? Well, that means 10 to the 3rd power because there's 3 zeros. And the second one, again, I don't see a numerical base, so 10 to the what power is equal to 1 over 100. Well, I reciprocate it, so I know that it's going to be a negative value, and then 10 to the what power gives you 100 to the 2 power. So to get the 1 over 100, I had to use a negative 2 power. Same thing for C. Base of 10 to the what power is equal to the cubic root of 100. Well, I'm going to rewrite the cubic root of 100 in a couple different steps. 10 to the x is equal to, this is 100 raised to the 1/3 power. Well, I can rewrite 100 as 10 squared. Well, what happens when I raise a power to a power? I multiply the powers. So now that my bases are the same, what's the value of x? 2/3. Okay. Something like D. Notice I see the natural log, so that means I have a base of e. E. Raised to the what power equals e. Well, you should know that anything raised to the first power gives us that number back. So e to the 1 is equal to e. So the natural log of e is 1. Natural log, so base of e to the what power equals 1. The only way to get something raised to a power equal to 1 is when that power is 0. So right there, those two problems, D and E, actually are some very important and special log properties. When your base and your argument are the same number, the value is always 1, because any base raised to the first power is that number. So log base b of b, if my argument's the same number as my base, that's always going to equal an exponent of 1. Same thing goes kind of for when your argument's 1. No matter what the value of your base is, when your argument's 1, that's always going to equal an exponent of 0. That's the only way to get 1 from an exponential form. And then lastly, natural log, so base of e to the what is equal to the argument of e to the 7th. Well, my bases are the same, so that means this is equal to 7. Lastly, we're going to evaluate, but this time we do have to use a calculator. Okay, when you're on your Casio, you do have a log button and you do see a natural log button. So the buttons are when you have a base of 10 or when you have a base of e. Well, what if you have a base that's not 10 nor e and you're trying to evaluate using the calculator? You can go to F4, which is math. If you're just on that run matrix screen, you can go to F4, which is math. And then if you look at F2, that you're going to see log AB. When you hit that button, log AB, it's going to look something like log with a little box here and then a box here in parentheses. So it gives you the option to type something here in for their base, and it gives you the option to type something here for the argument. So that's exactly what we're going to need in these next couple of problems. So for the first one, I typed that in. I put my base of 3. My argument is 7. I hit enter, and I get a decimal of about 1.77. All these are going to be decimals, so I'll be specific in your directions of how to round. I think for most of these, I'll round to the nearest hundredth or thousandth. When I see something like part B, the natural log of 4, remember, I don't need to put natural log base of e equals 4, or I'm sorry, of 4 equals what? I can just simply type the natural log button. That's right under e to the x power. That's kind of in the middle. So the natural log of 4 into my calculator is going to give me 1.386. When I type something in like C, again, I'm just hitting that natural log button. I want to type in 3e. So I hit the natural log, I type 3, and then when I put e, what happens is that you're going to get something like e to the blank. Well, if I just want 3e, what should I put for the exponent of e? 1. So I do have to type the 1 in there, but that's okay. I hit enter, and I get about 2.098. Excuse me. For something like D, I would actually rewrite that as a log in order to evaluate, because that's how we solve for an exponent is by using that inverse property of logs. So this is like the problem from above. This is going to be log base 2 of 6 is equal to x. So I do have to go to math, option F2, log base 2 of 6, hit enter, and I get about 2.584. And then the same thing for e. I'm solving for that exponent, so I can rewrite this as log base 10. But remember, when 10 is my base, I never have to write that. So I'm just going to say the log of 14 is equal to what? So now, like I said, I can just press the log button. I don't have to do log base 10 of 14. I can just press log of 14, hit enter, and that's going to give me 1.146. Now that's the end of your notes, but I do want to add in another problem. So what if I give you something like f? If I gave you e to the x is equal to 7, I would want to rewrite that as a log or in log form in order to evaluate on the calculator. So if my base is e, I'm not going to write log base e. Remember, that's the natural log, and I'm not even going to put the natural log base e. I'm just going to put natural log of 7, hit enter, and that's going to give me about 1.945. Okay, so now if you think about what we were doing in order to solve those application problems for the exponent, I said we don't have the algebraic skills to do that, so we let our calculator do it for us. Well, now we do, because to solve for the exponent in an exponential equation, we are using the inverse property, which is a logarithm. And so now you know how to write that log, you know how to convert from exponential to log form and log form to exponential form. You know how to evaluate logs with and without a calculator. If you have a TI calculator and you need to know how to put a log without a base of 10 or a base of e into your calculator, I can show you that, but I believe it's second window, I think it is, or alpha window or something like that. And then if you look, it's like option 4 or 5, you'll see like log base. And so that's what you would have to hit, and you would type in the different base in the argument. But I can show you that in person if you have a TI. All right, thanks so much. Bye.